Humanity has always looked up at the stars with wonder. We are a curious species, driven by a deep need to understand our origins and our place in the vastness of space. For centuries, we used only our eyes, then simple telescopes, to gaze into the heavens. Each new tool revealed a little more of the cosmic picture. Now, we have a new eye on the universe, one that sees farther and clearer than ever before. The James Webb Space Telescope is not just another telescope, it is a time machine. It is a portal to the distant past, allowing us to witness the birth of stars and the formation of the very first galaxies. This is a new golden age of discovery. The secret to the Webb telescope's power is its ability to see in infrared light. This is a type of light that is invisible to our human eyes. Much of the universe is filled with vast clouds of dust and gas, which act like a thick fog, blocking the visible light from objects behind them. But infrared light can pass right through this cosmic dust, much like X-rays can see through our skin. This allows JWST to peer into stellar nurseries where new stars and planets are being born, regions that were previously hidden from our view. Its giant golden mirror, over 6 meters wide, collects this faint light from the farthest reaches of space and time. This powerful vision lets us answer some of the biggest questions we have ever asked. Where did everything come from? How did the universe begin? The light from distant objects takes a very long time to reach us. When we look at a galaxy that is billions of light years away, we are not seeing it as it is today. We are seeing it as it was billions of years ago. The James Webb Space Telescope is powerful enough to see light from the universe's infancy, just a few 100 million years after the Big Bang. It is capturing snapshots of the cosmos in its youth, a time when the first stars ignited and lit up the darkness for the very first time. Every image the telescope sends back to Earth is more than just a pretty picture. It is a piece of a grand puzzle that we are slowly putting together. These images are filled with data, telling us about the chemical composition of distant atmospheres, the temperatures of faraway planets, and the powerful forces that shape galaxies. This is not just about collecting facts. It is about building a story. It is the story of the universe itself, from its fiery beginnings to the complex and beautiful structures we see today. The Webb telescope is our greatest storyteller, and it has only just begun to speak. For as long as we have known about planets in our own solar system, we have wondered, are there other worlds like ours out there? The James Webb Space Telescope is helping us answer that question with breathtaking clarity. It is a planet hunter of unparalleled skill, capable of studying distant worlds known as exoplanets. These are planets that orbit stars other than our Sun. By analyzing the starlight that passes through an exoplanet's atmosphere, JWST can detect the presence of different gases. This is like sniffing the air of a world light years away, searching for the chemical ingredients that could potentially support life. One of the most exciting discoveries comes from a planet named K218b, which is about 124 light years away. This planet is larger than Earth and is located in its star's habitable zone, the region where temperatures could allow for liquid water to exist on the surface. Webb detected carbon dioxide and methane in its atmosphere, which suggests that this world might be a Hycean planet, a world with a hydrogen-rich atmosphere and a surface covered by a vast global ocean. The possibility of a water world so far from home ignites our imagination and pushes us to keep searching for signs of life. Another fascinating world is 55 Cancri E, a rocky planet so close to its star that its surface is a scorching ocean of molten lava. Scientists thought that such a hot planet would have its atmosphere completely stripped away by its star's intense radiation. But JWST made a startling discovery. It found a substantial atmosphere, likely made of carbon dioxide and carbon monoxide. This suggests that the planet is constantly replenishing its atmosphere through intense volcanic activity. It shows us that planets are dynamic, active worlds and can be far more resilient than we ever imagined, changing our models of planetary science. These discoveries are transforming our understanding of planetary diversity. We are learning that the universe is filled with a stunning variety of worlds, from hot lava planets to potential water worlds, and everything in between. Each new observation adds another chapter to our growing catalog of exoplanets. We are moving from simply detecting these worlds to truly characterizing them, understanding their climates, their geology, and their potential for life. The search is no longer just about finding dots of light. It is about exploring entire new worlds, each with its own unique story to tell. Imagine traveling back in time, not by years or centuries, but by billions of years. Imagine witnessing the moment when the dark, empty universe first burst into light. This is the journey the James Webb Space Telescope takes us on. It is designed to capture the faint, ancient light from the very first stars and galaxies that formed after the Big Bang. This era, known as the Cosmic Dawn, has long been a mystery to astronomers. We knew the first galaxies must have formed, but we had never been able to see them. They were too far, too faint, and their light was too stretched out for older telescopes to detect. With its incredible sensitivity, JWST has shattered our previous understanding of the early universe. It has discovered galaxies that are far more massive and mature than our theories predicted could exist so early in cosmic history. Astronomers were stunned to find several massive galaxies that existed less than 1 billion years after the Big Bang. This discovery initially challenged our models of how galaxies form, suggesting that the process might happen much faster than we thought. It was a wonderful puzzle, forcing us to rethink the fundamental processes that built the cosmic structures we see today. Further investigation revealed another layer to this mystery. It turns out that many of these bright early galaxies are not just massive collections of stars. Their intense brightness is also powered by something else: supermassive black holes at their centers. These black holes are actively feeding on surrounding gas and dust, releasing enormous amounts of energy that make their host galaxies shine brilliantly across the cosmos. This tells us that supermassive black holes were not just a late addition to galaxies. They were present from the very beginning, growing alongside their galaxies and profoundly influencing their evolution. Looking this far back in time is like finding the first pages of the universe's autobiography. We are learning how the simple elements created in the Big Bang, hydrogen and helium, were forged into heavier elements inside the first stars. Those stars then exploded, scattering these new elements across space, providing the raw materials for the next generation of stars, planets, and eventually, for life itself. Every galaxy JWST finds in the early universe is a clue, helping us trace our own cosmic lineage back to the very beginning. We are, after all, made of stardust, and Webb is showing us exactly where that stardust came from. The discoveries of the James Webb Space Telescope do more than just expand our knowledge of faraway objects. They reshape our perspective of ourselves and our home planet Earth. By revealing the sheer number and variety of worlds in our galaxy, it reinforces the idea that the ingredients for life might be common throughout the universe. While we have not found definitive proof of life elsewhere yet, discovering planets with oceans and atmospheres brings us closer than ever before. It shifts the question from "is there life out there?" to "how can we find it?" This quest gives humanity a shared purpose, a grand adventure for all of us to follow. These cosmic revelations also enrich our understanding of our own solar system. By studying the atmospheres of exoplanets, we learn more about the planetary processes that shaped Earth and our neighbors. We can compare the hot, thick atmosphere of 55 Cancri E to that of Venus, or the potential ocean of K218b to the subsurface oceans we suspect exist on Jupiter's moon Europa and Saturn's moon Enceladus. The universe becomes a giant laboratory where we can see how different conditions lead to different planetary outcomes. This comparative knowledge is crucial for understanding Earth's own past and future, and what makes it so uniquely suited for life. The journey of discovery is far from over. In fact, it has just begun. The Webb telescope is just one of many new tools that will continue to push the boundaries of our knowledge. Future missions, like the Artemis program returning humans to the moon, and the Vera C. Rubin Observatory, mapping the entire southern sky, will build upon Webb's findings. Each new observatory, each new mission, adds another layer to our understanding. We are living in a revolutionary era of exploration, where the pace of discovery is accelerating, and the answers to age-old questions feel tantalizingly within our reach. Ultimately, exploring the cosmos is about understanding our own story. It connects us to the universe and to each other. When we look at an image from JWST, we are not just seeing gas and dust and light. We are seeing the raw materials that created our world, our sun, and ourselves. We are witnessing the grand cosmic processes that made our existence possible. The search for knowledge is one of the noblest human endeavors, and as we continue to point our telescopes toward the heavens, we are not just looking out into space. We are looking for our place within it, weaving our own small thread into the grand cosmic tapestry.